Hi all, this is Guided Practice 22. We're working on section 6.1, an introduction to trig. So again, we're working with our angles here, and we want to make sure that we can convert back and forth from radians to degrees, and that we can identify our coterminal angles. So when we are converting to degrees, we are starting with 11 pi over 6 radians, and we want to know how many degrees. So I typically here will set up the ratios. So the ratio is 2 pi radians over 360 degrees. And again, you can flip-flop that if you like. And I'm going to put my angle over on this side. And my angle is in radians, so it goes under the column that says radians. 11 over 6 pi, or 11 pi over 6. And then on the bottom is what we're looking for. We're looking for my angle in degrees. And then we go ahead and cross multiply. So x times 2 pi gives me 2 pi x. And then we'll have 11 over 6 pi times 360. Okay. And again, this 6 and it goes into 360 60 times. And we end up with 2 pi x is equal to 6 times 11 would give me 660 pi. And then we're going to divide both sides by 2 pi to get my x by itself. The pi's will cancel, and we will get an x equals 660 over 2 becomes 330. Okay. Number 2, this time we're going to convert to radians from degrees. By the way, this is a typo for me. This should really say 270 degrees. The way that I create that circle is with a slash CIRC, and I forgot the slash so that it just printed the word instead of the symbol. So I apologize for that one. And we're going to convert that to radians. So we're going to set up the ratio and the angle and the radians and the degrees. Again, it doesn't matter which way these go. In the ratio, you have 2 pi radians is the same as 360 degrees. And then the angle that we have is 270 degrees, and we're looking for that in radians. So we can go ahead here and cross multiply. So 270 times pi, 2 pi was going to give us 540 pi equals 360x. And so we're going to divide by 360 to get our x by itself. So we have 540 over 360x, and we want to reduce that. So if I take away the zeros, that's 54 over 36. And those are both evenly divisible by 9. So if I take 9 out of the top, that becomes a 6. If you take 9 out of the bottom, that becomes a 4, right? Reducing by 9s. And then reduce one more time by 2s, and that's going to give you 3 over 2. Sorry, not x, but pi. So it's 3 pi over 2, or 3/2 pi. 3 pi over 2. Either form is totally fine. You can also convert it to a decimal, but we typically think about radians in terms of a multiple of pi, right? 2 pi being all the way around. 1 pi is halfway around. Pi over 2 is a quarter of the way around, right? So that's why we think of it in terms of pi. It's a fraction of the pi, fraction of the circle, right? If I draw my circle, then this is 0. This is also 2 pi. So pi is over on this side. This is pi over 2. And this is 3 pi over 2. Okay. So it's what portion of the pi. Okay. All right. And then the last thing that we want to do is find 2 positive and 2 negative coterminal angles for 135 degrees. So what we're going to do, so angle number 1, we're going to take 135 degrees, and I'm going to get a positive coterminal angle by adding 360 degrees. So if you take 135 and add it to 360, we're going to get 495. To get a second positive angle, we're going to take 135, and we're going to go around the circle twice. So we're going to add 360 2 times. So then we're adding 360 to our 495 is going to give us 855. For angle 3, now we want two negative coterminal angles. So I'm going to start back at 135. And instead of going around in a positive direction, I'm going to go around 360 in the negative direction. So I'm going to subtract 360. And negative 225 would be our first one. And a second negative angles for angle number 4, we're going to start at 135 and we're going to subtract, we're going to go around the circle in a negative direction twice. So subtract 360 twice. And we get negative 585. Okay, so there are your two positives and your two negatives.